My name is Sakshi Rode and I am studying in final year of Instrumentation and Control Engineering Department in CUAP Technological University. Among the 5 topics, I opted for second topic, which was to describe the project I worked on. The name of my project is Automated Water Level Control System for Dual Tank using Ladder Logic and OPC Kepware. The plant consisted of 2 tanks, upper tank and lower tank. The field instruments were like 5 sensors: capacitive, pulse radar, magnetostrictive, guided wave and ultrasonic, 4 limit switches, 2 for upper tank and 2 for lower tank, pump and a motor, and also 4 solenoid valves. In ladder logic, the software used is RS Logix 500. The PLC used was Allen Bradley's Micrologic Series 1400. The basic algorithm behind the ladder logic was to operate the water from upper tank to lower tank through 1, 2 and 4 solenoid valves, and from lower tank to upper tank through 1 and 3 solenoid valves. While operating this, all the sensors were considered in analog inputs using a scaling function, where all the readings were taken care of. VFD was considered in AO, and DIs were considered in limit switches. All the solenoid valves and pumps were operated under digital outputs. A Modbus communication was also set up in this whole procedure, which further helped in OPC Kepware. Controller properties were tuned properly with respect to 4 to 20 milliampere. This whole ladder logic was operated under remote access. Now OPC Kepware. OPC Kepware is basically a bridge between the PLC and the field instruments. OPC Kepware was done under the software called MATLAB Simulink 2015. OPC Kepware had 3 function blocks: OPC write, read and configure. OPC Kep server was configured under OPC Kepware function. OPC read were used to read the data from the sensors reading, and OPC write was used to create the circuits. There were 2 aspects of for controlling this plant using OPC Kepware. First was to take one sensor, example capacitive sensor, as a standard reading input to the VFD. Basically, if the water level of the tank has reached the maximum level, then VFD should shut off automatically. The second aspect was to control the level of the tank using the VFD. VFD speed was automatically was controlled in such a way that we should attain the desired water level. While operating the plant using OPC Kepware, I understood which sensor works accurately, which helped me to determine that 3 sensors, namely capacitive, pulse radar and magnetostrictive, worked properly. And along with that, I also determined the static characteristics of the sensors. That whole project helped me in understanding the PNID, understanding and reading the PNID diagram, and understanding the connection between the field instruments and the panel. Along with that, I also understood to know and determine the specifications of the field instruments, and to set how the communication is set up between the field instruments and the software. Thank you.